Stanford University.
Okay, so the usual intro is how lucky you are to have the speaker. This time we mean it. Ben, I have known from the beginning of your career back in late 70s. I can't remember where it was when you were in Germany working on the beginning days of climate modeling and doing data analysis. My early memory of Ben was, hey, this is really statistically sharp guy, but he's too much of a straight shooter. Wait. So then over the years, we all did our quiet work that nobody really paid any attention to. And in 1994, the IPCC, the Intergovernmental Panel on Climate Change, as all of you know, in its second assessment report, had in Working Group 1 a Chapter 8, whose, I think they called them convening lead authors then, was Ben Santer and Tom Wigley, right? I think it was both of you guys. No, just you. Okay. That meant he was responsible for the chapter. And that chapter was based on a paper that Ben led a team of people on looking for fingerprints, he'll explain that, in the system. I gave you guys examples of them very quickly on the fly, but that's the guy who really did it first. And those fingerprints basically pointed to a discernible impact of human activities on climate. This triggered a massively ugly scene at it was the first massively ugly scene in the IPCC history at a plenary, which is where the 100 governments get together and have to approve the summary for policymakers word for word. And the guy being attacked was him. So it was because this chapter saying there was this discernible impact, though that word came out later but to that effect. And the chief Saudi negotiator basically said this was bad science, tried to drive a wedge between North and South countries, was very effectively doing it, and there was what is called a contact group. At a contact group, when you cannot agree in plenary, you go off and you negotiate. We negotiated like all day to get this language right. Now the Saudis, who made all the fuss, and the Kuwaitis never sent anybody, and they had many, many, many delegates. This one guy from Kenya came, and he had actually proposed dropping the entire chapter because he believed the Saudis. This was the Southern Solidarity. But this guy, meteorologist, not a famous science star, came and he watched this entire day, changed his mind, decided the process was fair and open. So we go back, and the normal practice in IPCC after a contact group where the group agrees is that the text is put up there on the screen and it is pro forma accepted, because if you started fighting over it again, you'd never get out. Well, of course, Saudis immediately raise their hand and Al-Saban starts in. This is unacceptable to us. So Ben has the temerity, this mere scientist, to say, but sir, your delegation made the most noise and you did not even have anybody at the group. And Al-Saban slams his fist on the table and it says, I am a representative of a sovereign country. You're just a scientist. You cannot talk to me like that. And we're a small delegation. We didn't have time. The Kenyan guy raises his flag. My stomach is in knots. And he gets up and he says, I'm a small delegation. I'm it. But I was convinced by the Saudis that this was really important. I went. I'm now satisfied the lead authors are correct. I withdraw my objection and urge everybody to vote for it. It passed. Then the Wall Street Journal started accusing him. You can tell about that? No, of scientific cleansing. Because in an IPCC report, every single meeting is correcting the language. So at the direction of the plenary, he corrected the language to which these guys in the Wall Street Journal redacted the components that were one of your words you just taught me, Meg, that were caveats, and said, therefore, this was a distortion of that. So there's this Mr. Mild-mannered Ben Santer, the statistician, quiet guy on the block, all of a sudden now out there as this object of derision by these manufactured, trumped-up charges of the ideology of no government control and the fossil fuel industry. Unfortunately for them, Ben very shortly thereafter got a MacArthur Genius Award, not just because he stood up to them, but primarily because this was the first scientific study really showing that there was a discernible impact of human activities on climate by good statistical testing. So Ben has now worked in many other areas. He's showed why the satellite measurements were valid, but not the way the original guys showed it. Why a series of recent papers now, which purport to show that the mainstream is wrong, should never have gotten through peer review and so forth, for which he's been FOIA attacked. He'll tell you all about that. And so here, Mr. Mildmanner will come up here and tell you what life in the scientific fast lane is like when you hurt the interests of trillion-dollar industries. Ben?
Thank you, Steve. It's very nice to be here tonight, and it's very nice to be out of my office, actually. I've spent the last 4 months since the ClimateGate events unfolded, not doing science, but essentially defending friends, defending myself against allegations of scientific misconduct, and trying to set the scientific record straight. And I'm going to tell you a little bit about what has caused me the most personal concern in the whole ClimateGate affair. My concerns and my difficulties over the last 4 months relate to a scientific paper I published in 2008, and that's what I'm going to tell you a little bit tonight. And it's really sort of a morality play in a way. It's a story about science, non-science, and nonsense. Steve mentioned the satellite data. These are satellite records of atmospheric temperature change since 1979. And in our field, there's been this huge conundrum for many, many years, actually since 1990, because the original guys who looked at these satellite data sets and analyzed them and tried to splice them together and create some homogeneous record of climate change since 1979, their original work suggested that the atmosphere was cooling. And that was a huge problem for us, because the surface thermometer record suggested that the surface of the planet was warming. How could the surface be warming, yet the air above it be cooling? All climate models have told us really since the 1960s that in response to human-caused increases in greenhouse gases, the atmosphere should warm, particularly in the tropics, for reasons I'll get into later. So this really seemed to be some fundamental problem for our field, a contradiction between these satellite measurements, basic theory, and the surface thermometer record. And I'm going to first of all give you a brief history of this debate up to 2006, when we all thought we had resolved this thing and finally put it to rest, but we were wrong. It actually came back in 2007 and 2008, and this controversy endures even through to today, although scientifically there's really no reason for it to continue. And in order to discuss the non-science and the nonsense, I need to get a little bit into some statistical issues, but I'm only going to show a couple of equations, and the statistical issues here are really rather simple. And then finally, I'm going to deal with climate auditing, Freedom of Information Act request, and ClimateGate, and what I've had to deal with after publication of our paper in 2008. Okay, first of all, inconvenient observations. Again, for a long time, there's been this notion out there that satellite data, satellite measurements of atmospheric temperature change prove unambiguously that there is no human effect on climate, and that the surface thermometer record is wrong. And I guarantee you could read something like this in your local newspaper, national newspaper, for many years. Even now you can probably read similar statements. I'm not picking on Mr. Schlesinger here, but this is a particularly egregious example. He said, writing in the LA Times in 2004, satellite measurements over 35 years, he got the number of years a little bit wrong, show no significant warming in the lower atmosphere, which is an essential part of the global warming theory. So let's look at that claim. How do satellites actually measure atmospheric temperature? Well, it turns out that oxygen molecules are fairly homogeneously distributed throughout the atmosphere, and their microwave emissions are proportional to the temperature of broad layers of the atmosphere. So by measuring the emission of oxygen molecules using these microwave sounding instruments, and by looking at different frequencies, you can actually back out the temperatures of different layers of the atmosphere. The lower troposphere, so the lowest layer of the atmosphere, the lower stratosphere, the mid to upper troposphere. And the first guys to do this really were folks at the University of Alabama in Huntsville. Much of the focus in this great satellite debate, let's call it, has really been on temperature measurements in the lower 7 to 8 kilometers of the atmosphere. As I mentioned, initially it was just one group at the University of Alabama at Huntsville, John Christie and Roy Spencer, who took on this very difficult job of trying to construct climate quality temperature records from these satellite data sets. And their records initially suggested this cooling of the atmosphere. In the late 90s, a second group here in California, actually a private company called Remote Sensing Systems, threw their hat into the ring. One of the fellows involved in that effort was Matthias Schabel, who was a former student of Steve's here at Stanford. Other groups have now thrown their hats into the ring too, but for a long time, these were the two main protagonists there. This was the problem. Okay, so what you see here are two traces, two wiggly lines. The red line is an estimate of temperature changes in the tropical atmosphere, so roughly 20 north to 20 south, at the surface, at the tropical surface, from 1979, the beginning of the satellite record, through to, in this case, this was something like 2006, 2007. The blue line is from the University of Alabama group. It's their estimate of temperature changes in the tropical lower atmosphere, the lowest 7 to 8 kilometers of the atmosphere. And you can immediately see the problem there. If you look at the overall temperature change over this 25 plus year period, the satellite record suggested that there had been cooling, whereas the surface record suggested strong warming. Now there's a lot of noise. That's the other thing to note immediately. There are a lot of wiggles, and as climate scientists, we understand the causes of these wiggles. For example, these red blobs here are associated with large El Nino events. This here is one of the largest El Ninos in the 20th century, the 97-98 El Nino event. El Ninos on average tend to warm the planet. Here, this is the big 82-83 El Nino event. You can also see the signatures of volcanic eruptions. This, for example, here is the cooling after the El Chichon eruption. This is the cooling here after the Pinatubo eruption. So we know a lot of the reasons for the wiggles on the red curve and the blue curve. What we didn't understand is why one showed cooling, the satellite record, and why the surface temperature showed warming. Now, the Santa Rosa group looked at the same raw satellite data, the same raw bits and bytes. Okay, I'll just toggle between these two pictures. Compare the blue line and the black line. Okay, so the red line, the red trace is the same. That's the surface temperature record estimated by a combination of thermometers and satellites measuring surface temperatures. But the black and the blue lines are the two groups' estimates using the same raw data of the lower atmosphere temperature change. You can see the Santa Rosa group actually shows stronger warming than the surface record over the satellite era. So how could these two groups, using the same data, arrive at fundamentally different estimates of the temperature change, estimates that differed in terms of the sign of the change? This is the best observed period in Earth's history. How come? Why did they get different results? Well, it turned out that the answer was related to satellite drift. What you see here, plotted on the y-axis, is something called local equatorial crossing time. It's a measure of the time of day at which a satellite, these are polar orbiting satellites, sees a certain location on the Earth's surface. And here you see a whole bunch of satellites, and the length of the line is the lifetime of the satellite. Let's look at NOAA 11 here. What you can see is that over its roughly 6-year lifetime, the time of day at which it saw a given location on the Earth's surface drifted systematically. It drifted by over 4 hours. Now, as you can easily appreciate here at our latitudes, we have big daily temperature cycles. Whether I make a temperature measurement at 4 in the afternoon or at 8 at night matters. And clearly, if there's some systematic drift in terms of the time of day at which you're making an observation, you have to account for that. Well, the Alabama group recognized that this was a problem, that they had to account for this drift effect, but they got the sign wrong. They literally got the sign wrong. They made a sign error in correcting for the effects of satellite orbital drift. This all came out in a series of papers that were published in Science in 2005. There were 3 papers. They were published in the same issue. One of the Alabama group argued that there had been a conspiracy to publish these papers at the same time. There was no such conspiracy. These were independent efforts here. The first paper was by the guys at Santa Rosa, and they were the ones who identified the sign error in the Alabama group's correction for the effects of satellite drift. They did it right. When they did it right, they got the black line, which I've showed you. Let's just go back to that. This was their estimate then of temperature changes in the tropical lower atmosphere over the satellite record. The Alabama group had for a long time argued, well, we can't be wrong here because we're in almost perfect agreement with independent measurements from weather balloons. Now, weather balloons have been making measurements of atmospheric temperature since the 1940s, actually, but in a big way since the 1960s. And typically, these are weather balloons that are launched at hundreds of locations around the Earth's surface. They carry thermometers, and they make measurements typically at midnight and at noon. Now, what's happened over time is that those thermometers carried by the weather balloons have to be shielded. And they have to be shielded because, as you'll appreciate, a thermometer left out in direct sunlight is affected by that direct sunlight. That direct solar heating of the thermometer contaminates the measurement. People recognize this with weather balloons, and they had thermal shielding for these thermometers. Over time, that thermal shielding got better and better. That introduced some non-climatic bias in the weather balloon data. Now, the second group was a bunch of scientists at Yale University and at the Geophysical Fluid Dynamics lab in Princeton. And what they did was very clever. Remember, the weather balloon data are from 2 times, from midnight and from noon. They compared the midnight data with the noon data. It turned out that the midnight weather balloon data showed strong warming of the lower atmosphere. The noon didn't. And those differences between the midnight and the noon results were coherent throughout the atmosphere. And the differences actually got larger the higher up you got in the atmosphere, which makes sense because the higher up you get, the thinner the atmosphere, the stronger the solar heating effect, the more important that bias is. It's a beautiful piece of detective work. Actually, both of these studies, this was hard, laborious work, and I think that both groups of scientists there deserve medals as big as soup plates for really mapping out the problems with the Alabama data set and really showing the problems of arguing that you're in agreement with some independent data set if that independent data set is wrong. Our paper, which was the third paper, showed that when you looked at these adjusted satellite data sets, which didn't have the sign error for orbital drift effects, and you looked at adjusted weather balloon data sets, which didn't have this problem with the change in the thermal shielding over time, there was no disagreement between climate models and what they told us about the expected changes in atmospheric temperature, between observations, and between basic physical theory. We thought we had resolved the problem. And this was the first report of the US climate change science program It came out in April 2006. It was the first of 21 reports to the US Congress on many different aspects of climate change. Roughly 24 of us worked for 2 years on this report, and it involved all the major protagonists: the Alabama group, the remote sensing systems group, experts in weather balloon data, experts in surface temperature data, climate modelers. It was very unpleasant, but this was our bottom line conclusion. And this was a process really that did not exclude dissonant voices, it involved them. We thought we had really nailed this problem. I'll just read this conclusion. Previously reported discrepancies between the amount of warming near the surface and higher in the atmosphere have been used to challenge the reliability of climate models and the reality of human-induced global warming. This significant discrepancy no longer exists. End of story, right? Not quite. So that was in 2006. What happened in 2007? In 2007, a paper was published in the International Journal of Climatology, a journal of the Royal Meteorological Society in the UK. The first author was Professor David Douglas, an astronomer at the University of Rochester. The second author was John Christie, who was involved in the development of the Alabama data set that I've just talked about, the Alabama satellite data set. This paper made the following claims. These gentlemen devised what they called a robust statistical test, and based on that test, they concluded that models and observations disagree to a statistically significant extent. Now, I should point out here that this conclusion was based on the same data that we had used 1 year earlier in this report, the one that I mentioned here, this first report of the US Climate Change Science Program. So these folks claimed, based on their paper and based on analysis of the same data, that they obtained a fundamentally different conclusion. Again, how could they get that fundamentally different conclusion? They claimed then, this is another one of the co-authors of that paper, Fred Singer, based on that single paper, nature, not human activity, rules the climate. This was the centerpiece of Fred Singer's so-called NIPCC report, the Non-Governmental International Panel on Climate Change report. And Fred Singer also held a press conference after the Douglas et al. Paper was published at the US National Press Club. He claimed that the findings from this paper constituted an inconvenient truth and proved that nature rules the climate. Human-produced greenhouse gases are not responsible for global warming. These were extraordinary claims. They were claims that one paper had really turned the world of science on its head and somehow magically counteracted literally hundreds of scientific papers that showed that there was a profound human effect on climate. How could they make this claim? Okay, in order to look at how they could make that claim, we need to get very briefly into some statistical issues. Imagine you have a very, very simple equation, simplest form. You have a time series like the ones I showed you previously, some overall change, maybe a warming, maybe a cooling, and a lot of wiggles superimposed on it, a lot of up and downs. Well, we can separate that time series into a signal component, say some slow overall trend, some warming in response to human-caused changes in greenhouse gases, for example, and noise, what we call natural internal climate variability. That's, as I've showed you, wiggles that are associated with things like El Niños, which tend to warm, La Niñas, which tend to cool, and other things that we know and love as climatologists, like, for example, the Pacific Decadal Oscillation, North Atlantic Oscillation. There are many different beasts, many different modes of natural climate variability that constitute this internal noise. So imagine, if you will, that you've got this Harry Potter-like statistical magic wand, and you can wave it over one of these time series, and you can separate it into those two components, a signal component and a noise component. Now, we can actually kind of look at this in climate model data, and you can very nicely see what I mean by signal and noise. This is from a climate model, a Japanese climate model. These are from experiments that were performed in support of the IPCC's fourth assessment report in 2007. What you see here are tropospheric temperature time series. And you can see that there's this black line here is this small overall warming trend. This is an experiment where a model is driven by changes in greenhouse gases, changes in the sun's energy output, changes in aerosols, ozone. We call them also colloquially everything and the kitchen sink experiments, where you try and drive a climate model with your best estimate of the actual factors that have been important over the 20th century. And you can calculate from this climate model something akin to the satellite temperatures that I've showed you. And in this particular run of this Japanese model, you have a La Nina, that's that blue thing near the end, which tends to cool it down. And you have an El Nino near the beginning, that's the red thing, which tends to warm things up. Because this is a short record, only a little over 20 years, and you have a warm blip near the beginning and a cool blip near the end, you don't get much overall change. Now, when you run the same model, but starting from a different initial state, back, say, in 1850 or so, you get some different sequence of El Niños and La Niñas. These are free-running models, if you will. They generate their own climate noise. And if you start from different initial conditions, very soon you get a different sequence of El Niños and La Niñas. You see that very clearly here. This is, again, the same model, the same human-caused forcing factors that it's being run with, but it has a different sequence of El Niños. In this case, it has an El Niño near the end of the series and a La Nina near the beginning, so it shows a larger overall warming trend because it has a cool blip near the beginning and a warm blip near the end. And you can see the same thing here. This is the same model, just different realizations. And each one of them has a slightly different sequence of wiggles, ups and downs, different overall trends. This is the effect of noise. This is climate noise. Obviously, in the real world, we don't have the luxury of rerunning the real world many times. We only have one sequence of climate noise and one sequence of how the real world has responded to human-caused changes in greenhouse gases. But in the climate model world, you can essentially sort of rerun the 20th century many times and get many different sequences of these things. And what you do then at the end is you average over all of these things. You average over these 5 realizations, and that beats down the noise because the noise is not correlated from one realization to the next. So you get a better estimate of the thing you're really interested in, which is the slow overall increase in temperature, in this case in response to human-caused changes in greenhouse gases and all that other nice stuff. No, these experiments include human-caused changes in well-mixed greenhouse gases. They include changes in aerosol particles, actually sulfate aerosols and soot aerosols. But they also include changes in the amount of volcanic dust in the atmosphere and estimated changes in the sun's energy output. So that's what I meant by everything and the kitchen sink. This type of experiment, you take a climate model and you drive it by our best estimate of the historical forcing factors that have operated in the real world. But again, you have to do this many times because you don't know the true initial conditions of the system back in 1850. And even if you did, you would very rapidly diverge away from them due to essentially chaotic variability in the climate system. So the key thing here is that you can study this noise and you can see that there's uncertainty in estimating what you really are interested in, this trend, the response of the system to the things that you've changed. And you've got to account for that uncertainty. Any comparison between models and observations has to account for that kind of uncertainty.
But the ocean temperatures were internally calculated.
That's right, yeah.
That's why the El Nino, La Niñas are kind of random in when they occur.
Right. Again, this is a coupled model of the atmosphere and ocean. So what's actually happening is it's not assimilating, it's not taking in observations of temperature, it's generating its own El Niños and La Niñas. And that's that's why each realization is different, because each realization has a different sequence of El Niños and La Niñas.
We call that internal, and what Ben was talking about is external, which has no control.
So the key thing here, the key point I want to make is there's uncertainty in estimating the black line, the trend, the change in temperature due to the things you've actually changed in the experiment, like greenhouse gases. And any statistical test has to account for that. Now that was a model. As I've showed you, these are observations, and they show the same ups and downs and wiggles, and show you that we don't know this trend very well, particularly in the tropics. There's a lot of noise, and you've got to account for that uncertainty in estimating this thing of interest. And again, these wiggles, these ups and downs, are largely associated with changes in El Nino behavior. This is some trace, some estimate of changes in temperature in a key region of the Pacific that's used as a sort of index of El Nino strength. And you can see that there's a very nice relationship between many of these wiggles here and El Nino behavior. So the bottom line is that in the real world and in the model world, there's noise. When you want to compare the model black lines with the observed black lines, you better account for that noise. It's important. This just shows you again this big El Nino in 97, 98, and the big El Nino here in 82, 83 in the real world. Okay, so what did Douglas et al. Actually do? What was the statistical test that they came up with? Their test looked something like this. So first of all, they said, if we have a big collection of climate models, say 19 or 20 different climate models, we'll take the average trend in those 19 or 20 different climate models. And what we'll do is we'll subtract from that average of all the model results the single observed trend, and then we'll divide by some term that they called the estimate of uncertainty in the multi-model average trend. And that estimate of uncertainty was something that statisticians called the standard error of the mean. It's an estimate of how well you know some mean quantity from a finite sample of results. In this case, what that standard error was, it was the standard deviation of these 19 or 20 numbers, these 19 or 20 trends from a bunch of different models divided by the square root of the number of models. Let me show you what that looks like. So here are 19 different climate models. These are the ones that Douglas et al. Used in their test. And what you see there on the y-axis is the temperature trend in the tropical lower atmosphere. So again, this is the lowest 7 to 8 kilometers of the atmosphere. And the black line there is the average of those 19 numbers. So in their terminology, this is this BM, the model average trend in tropospheric temperature. Now, the colored bars there are their sigma SE terms, so their measure of the uncertainty in the model average. And the yellow is 2 times the uncertainty in the model average, and the brown is 1 times the uncertainty. Here are the observations. So the black dot there is from the Santa Rosa group. That's their estimate of tropical tropospheric temperature changes over the satellite era. And the open circle is from the Alabama group. And you can see immediately then that the black circle and the open circle are outside the envelope that these guys calculated, the envelope of uncertainty on the model result. And that's why they concluded that the models were fundamentally inconsistent with the observations. But you can also see, if you look, without even thinking about this very much, that if you applied their test to each of the individual models, then 11 of the 19 models would be deemed not models. They'd be sort of deemed inconsistent with the model average. Any test that says that half of the things that you use to perform the test are actually inconsistent with the average is a really, really weird test. This is not even an undergraduate type of error that you would make in the first year of statistics. This is just, it doesn't pass any of the most basic sanity tests. Okay, so what did they do wrong? First of all, they assumed that trends are perfectly known in both models and observations. That's wrong. As I've showed you, noise is an important factor, and you have to incorporate the uncertainty in estimating trends as part of your test. That's really important. They didn't do that. The other thing is that this sigma SE term, the standard error of the mean, is not an appropriate basis for performing a statistical test. Again, it's something that you use in statistics to say, how well can I estimate some average from 19 numbers, but it's not something that you would use as the basis for performing a statistical test. Certainly not for determining whether the average of a collection of model results is consistent with a single uncertain observed trend. So as I've already showed you, when this paper was published online in late 2007, it attracted extraordinary attention. Fox News picked it up, press conferences held, the Department of Energy contacts me and asks me for some response. The paper attracted attention at the highest levels of government, actually, at the National Oceanic and Atmospheric Administration and at the Department of Energy. So I decided, after discussing things with a number of colleagues, that some form of response was necessary. Rather reluctantly, having just spent 2 years of my life on the first report of the US Climate Change Science Program. But it was so clear that something was wrong in this paper and that needed to be brought into bright daylight.
I think that had 5 criminals on it.
Oh, let's see how many criminals are, yeah. Okay, so there's Santer, Wigley, Solomon, Jones, Carl, 6, Schmidt. 6 criminals. 6 criminals. This was obviously a conspiracy of the first order, yeah. Okay, so the first thing is, let's remember what Douglas et al. Did. This is exactly the same thing, but now you see these error bars here. These are estimates of the uncertainty on the observed trend. And it's rather easy to calculate them. They're very large, not surprisingly, given all those big wiggles that I showed you. Clearly, when you incorporate the uncertainties on the observed trend, they easily overlap with the average of all the model results. And it turns out that when you do that, of course, there is no statistically significant difference between the models and the observations. And again, you know, you could see that visually too. Here again is the remote sensing systems result. Look at the number of models that are actually very close to, I mean, how could they possibly conclude that all models were fundamentally inconsistent with observations, which is what they concluded. Okay, but people might say, well, your test is flawed too, and I don't believe that the test that you've come up with that incorporates this uncertainty in the observations is a meaningful or appropriate test. One way of addressing that kind of criticism is by performing tests with random data. You can use very simple statistical models. There's an example of one there, autoregressive models we call them, and you can fool around with random data. You can generate many thousands of time series. Here are 2 examples. This is one synthetic time series generated using this equation up there and a random number generator, which happens to produce a time series that shows some overall warming trend. This is one that shows an overall cooling trend. You can do this many, many thousands of times, and you can apply their test and you can apply our test, and you can see how both tests perform under these controlled conditions, where you know that the only differences you should see between these synthetic time series are due to chance alone. Okay? So that's what we did. And here you see the results of that. This is essentially here on the x-axis, sort of the number of models that you use in this test. Remember, we're not using actual model data, but it's the number of time series that we're using in this test. And what you see on the y-axis there is the number of times you would conclude, or the percentage of times that you would conclude that these synthetic time series are statistically different. And statisticians know that if you conduct a bunch of tests, then, and you're looking at differences between these time series at the 5% significance level, then 5% of the time, roughly, with random data, you should expect to see significant differences. And if you're conducting differences, looking at significance of differences at the 10% level, then roughly 10% of the time with random data, you'd expect to see significant differences between these random data sets you're generating. And that's exactly what we got with our test. There's a small bias. I won't go into the technical reasons for that, but our test basically behaved very close to theoretical expectations. This is how the Douglas et al. Test behaved. Now, you can see that asymptotically, as you increase the sort of number of time series that you're looking at, because of this square root n term in there, what happened is that more than 80% of the time, with randomly generated data, their test would conclude that the random data sets were significantly different. It was absurd, just completely absurd, demonstrably wrong. We're not talking about shades of gray difference here of opinion between reasonable scientists. We're talking about something that was simply incorrect.
Ben, who peer-reviewed this? Should never have gotten.
I'll get into that a little bit later. Okay, so these were the bottom line conclusions of our paper then. We found that there was no fundamental discrepancy between models and observations in the tropical atmosphere. The Douglas et al. Claim was based on older data sets. They had actually ignored data sets that showed warming of the tropical atmosphere, even though they had those data sets in their possession. But more crucially, their claim was wrong because it was based on two serious methodological errors. They assumed that the trends in the observations and the models were perfectly known, no uncertainty, which was clearly wrong, and they applied this inappropriate statistical consistency test, which they had devised themselves. Now, you would think, wouldn't you, that if you come to a conclusion that claims to turn the world of science on its head and claims to undercut the findings of the IPCC's fourth assessment report, claims to undercut the findings of the US Climate Change Science Program report, you would ask why? Why did we get a completely different result than these other guys? We're using the same data that they did. They did not ask that question. They got a result that they liked, and they published that result. Okay, so once our paper was published, Nature wrote a little thing saying, this is now the end of the story. The riddle is resolved here. We thought so too, but it wasn't the end of the story. It's kind of like the beast that will not die in some bad B-grade Hollywood movie, and it keeps on trying to get me all the time. Yeah, zombies, yeah. So our paper was published online in the International Journal of Climatology on October the 10th, 2008. 10 days later, I received a request from Mr. Stephen McIntyre, who runs a website called Climate Audit, for the model monthly data used for the statistical analysis in our paper. I was on travel at the time. I did not get back. I did not check my email while I was away. I eventually replied to Mr. McIntyre and basically told him, if you want to audit the findings of our paper, feel free to do so. The climate model data that we use are freely available. In fact, 3,500 researchers around the world use the climate model data that we have archived at Livermore. It's an open database. Hundreds of scientific papers have been published with that. Mr. McIntyre had in his possession, or had the ability to access, exactly the same data that we had used in our study. And indeed, I should point out that the Douglas et al. Paper used this same archive. That's what they did. They didn't use anything from us. They went back to the beginning, to their credit, and actually calculated their own satellite temperatures from climate model output. But this was not what Mr. McIntyre wanted. He did not actually want to go back to the raw data. He then sent a Freedom of Information Act request to the National Oceanic and Atmospheric Administration. He did that because I had a number of NOAA co-authors on the paper. In addition to the output from the climate models, he also requested several years' worth of my own personal email correspondence. And he then issued a second Freedom of Information Act request to the US Department of Energy. He began to express moral outrage on his blog. Santer was stonewalling him. I began to get hate mail. I began to get threatening letters. Letters were written to the director of Lawrence Livermore National Lab, to my funding agency, saying that I was bringing the reputation of Lawrence Livermore National Lab into disrepute. That's how this particular game works. And I was spending all of my time dealing with this sort of stuff. I decided that I did not want to do that I wanted to continue being a scientist and doing science. As far as I was concerned, I had already wasted nearly a year of my career replying to the Douglas et al. Paper, a paper with serious scientific flaws which should not have been published. I did not want to spend further years of my career dealing with Mr. McIntyre and dealing with legal investigations. I released then all the intermediate data that I had calculated from the raw climate model data. I did that on January the 13th, 2009. Again, the raw climate model data that I used was freely available to anyone in the world, even Mr. McIntyre. These are just a couple of excerpts from Mr. McIntyre's climate audit blog, and I've highlighted one at the top, which is actually from Mr. McIntyre himself. Santer wants to try this kind of stunt, as I've said above. I've submitted Freedom of Information Act requests, and we'll see what they turn up. We'll see what the journal policies require. I'll also see what DOE and PCMDI, that's where I work, the Program for Climate Model Diagnosis and Intercomparison, administrators have to say. We'll see if any of Santer's buddies are obligated to produce the data. We'll see if Santer ever sent any of the data to his buddies. This did not give me a warm and fuzzy feeling that this was a scientific peer who was truly interested in scientific discovery and in better understanding the nature and causes of climate change. And there were all sorts of people offering their legal services to Mr. McIntyre to prosecute me for my unreasonableness. So I think this all boils down to a couple of issues there, this Freedom of Information Act request stuff. And as you can see, this is at the heart of much of ClimateGate. Phil Jones got into the difficulties he did, I believe, because of Stephen McIntyre. Stephen McIntyre submitted over 60 Freedom of Information Act requests to the Climatic Research Unit in a fairly short space of time. I believe that the purpose of those requests was not valid scientific discovery, but harassment. And that's very troubling to me. What questions do McIntyre's Freedom of Information Act request raise in our case? First of all, as I've said, what he actually wanted were the intermediate calculations that we had done from the raw climate model data. So a reasonable question is, did we do those intermediate calculations correctly? Now, we had already been audited. Douglas et al., to their credit again, had gone back to the raw data. They had already found very similar intermediate results to the results that we had. The difference between Douglas et al. And the Santer et al. Paper was never in the intermediate calculations. It was in the statistical tests that the two groups had used. So McIntyre's request was completely frivolous because we had already been audited effectively on the first part of the problem. Did we do the intermediate calculations correctly? Did we apply the appropriate statistical tests? Again, as I've showed you, one doesn't have to stand up there and say, trust me, I have a lot of expertise in doing this. There are ways of adjudicating. You can look at how these tests perform with randomly generated data. Clearly, as I've showed you, the Douglas et al. Test fails. It does not perform according to expectations. It does not perform as a reasonable statistical test should perform. And indeed, asymptotically, if you just increase the number of models in the test, you would find that infinitesimally small differences would be judged to be highly significant in the end. This test was clearly wrong. and ours performed according to theoretical expectations. So question 2, yeah, we had examined how these 2 sets of tests performed. Ours performed according to theory. The Douglas et al. Test did not perform according to theoretical expectations. Question 3, and this is the more difficult one. What is our legal responsibility as scientists? Are we required to provide self-appointed auditors who have no training in climate science everything that they ask for? Every single little thing. Email correspondence, intermediate calculations, explanations of how to use computer codes. These are all things that have been requested in the past. Do we have that requirement? And if we don't give some self-appointed auditor everything that they request, can they make our lives miserable and write to our superiors and funding agencies and initiate congressional investigations? These are not hypotheticals. All this has happened and is happening, as we see. This is why I am in trouble now. I am in trouble for setting the scientific record straight on a paper that should not have been published. I don't think we have that responsibility. I think we have a reasonable responsibility as scientists to ensure that others can replicate what we have done, that they have in their possession all the data that we used at the outset of our study, and that they can see whether we did all calculations correctly and whether we drew appropriate conclusions based on those calculations that we did. I think that's our responsibility, to ensure reproducibility is possible, but I don't think it's necessary to give these self-appointed auditors every little thing they can possibly think of. Finally, again, as I said at the outset, this is a story about science, about non-science and nonsense. These are important scientific issues. We really need to know whether there are fundamental discrepancies between models and observations, whether there are inconvenient observations out there. We and others have studied that for decades now. We haven't managed to find those killer, inconvenient observations. But for the longest time, the satellite record was held up as an iconic example of something that gave the lie to all computer modeling, to all other observational data sets, to basic theory. The non-science is what Douglas et al. Did. Again, they did not behave as normal scientists would do. They used the same data that others had used, models and observations. They got fundamentally different results after devising their own statistical tests. And rather than then probing and asking, is our test appropriate? Are the inferences that we drew appropriate? They just ran with the result that they got. And the nonsense, I think, is what Mr. McIntyre has done. All of this expression of moral outrage on his blog and playing this game where you literally incite other people to hatred and get them to do all sorts of things that have nothing to do with science whatsoever and nothing to do with search for scientific truth. Again, from my perspective, Mr. McIntyre had access to all the information he needed, both model and observational data, to test our findings and determine whether we were right or whether we were wrong. I think he's using Freedom of Information Act requests, not only in my case, but in many other cases, as a means for harassing and intimidating other scientists. I think there's a calculated attempt here to mandate the scientific equivalent of what people used to call no-go areas in Northern Ireland. You go there and come up with results we don't like, we'll be down on you like a ton of bricks. And paleoclimate is one of those no-go areas now. And also the microwave sounding unit data, satellite data, that's another one of those no-go areas. I don't think we can let this kind of stuff stand. Now more than at any other time, we urgently need people looking at these key areas of climate science, not being intimidated by bullies. One of the really troubling things is the asymmetry in this auditing. Mr. McIntyre purports to have considerable statistical training, yet he did not audit the Douglas et al. Paper, which had a grievous and very obvious statistical error. If someone really were interested in dispassionately getting to the bottom of things and figuring out why two papers reach fundamentally different conclusions, they would not behave in the way that Mr. McIntyre has behaved. Again, I don't think we can be cowed or intimidated by this kind of stuff, but it's painful, and it's going to continue to be painful. ClimateGate tells us that there are folks out there, there are forces of unreason who are not really interested in improving our understanding of the science. And the very sad thing to me is that even after publication of our paper, Douglas et al. Have not admitted any error in what they did. And what happened, this is a timeline of the key events, what's happened to me over the last couple of months, if you look here right at the end, based on their selective analysis of the hacked emails from the Climatic Research Unit, David Douglas and John Christie published something in an online thing called the American Thinker, in which they accused me of serious professional misconduct. They did not admit any error in their statistics, but they accused me of conspiring to delay publication of the print version of their paper. Again, their online paper was published 10 months before our paper. Their paper was, again, published in December 2007. Our paper was finally published in October 2008. The editor of the International Journal of Climatology decided to publish both the Douglas et al. And Santer et al. Papers in the print version at the same time. That was the editor's decision, not my decision. But in this piece here, I was accused of somehow using my evil powers to persuade the editor of the journal to hold back publication of the print version of the Douglas et al. Paper. And that has then, that and my response to Mr. McIntyre's Freedom of Information Act requests are now the subject of investigations by both Senator Inhofe and by Representative Barton. So again, that's the end of my story. It's not over yet, obviously. It is a kind of morality play for me. I guess to be filed under the category, no good deed goes unpunished. But it's important to do this kind of stuff. Science is not self-correcting. There's no magical self-correcting mechanism out there. When an incorrect paper has been published and extraordinary and wrong claims are made on the basis of that paper, people have to do the work of exposing the errors, trying to remedy the errors, trying to explain what went wrong, trying to do it right. And there is cost involved in doing that, but that does not absolve us from the responsibility of trying. So thank you very much, and be glad to try and answer any questions you have.
What has been the response of the government agencies to the Freedom of Information Act request to date?
It's the law of the land. Oh, sorry, the question was, what was the response of government agencies, in this case, both NOAA, the National Oceanic and Atmospheric Administration, and the Department of Energy, to these Freedom of Information Act requests? NOAA's response was, we don't have the data Mr. McIntyre is requesting, only Ben Santer has that. DOE, it was unclear how they were going to respond. It was left up to me, essentially, to decide whether I wanted to try and fight this request and potentially spend years of my scientific career doing that, or whether I wanted to release these intermediate calculations, which is, in the end, what I decided to do. I should point out that I made that release to the entire scientific community, and I released everything that I had calculated, not just the intermediate calculations requested by Mr. McIntyre. I did that, I would have to say, somewhat reluctantly, because I think there is a principle here. Again, I believe that I had been compliant with the letter and the spirit of the Freedom of Information Act by telling Mr. McIntyre, if you want to reproduce what we've done, you have access to the same data that we used. And I do think it is troubling to set this kind of a precedent, but it's a judgment call, and in my judgment, I was more useful and happier doing science than spending years of my life in litigation. And it was unclear then, if it did come to litigation, to what extent the Department of Energy was prepared to back me. Yes, sir.
Well, do you see a change in this world of scientific intrigue with the new administration now in office for a year, and they're making a big effort to return the government to science and take the politics out of science? Have you seen a change from your perspective?
The question was, have I seen some change with the change in administration over the last year in the government's ability to defend science? Is that what you're asking, or?
To end the 8 years of stifling the science, basically from not just your center, but from other government-funded science centers around the country.
Well, I have to say that I did not actually experience all that much in the way of stifling of my science in the previous administration. I was pretty much allowed to do what I wanted to do. There were people unhappy about what I did, but I did not really have direct experience with use of the Freedom of Information Act request until this last year. And that has been a bit of a shocker to me. I had thought that the Freedom of Information Act request, while clearly noble in intent to enhance transparency in government, could not be used in this way. I thought that there had to be cause, that someone couldn't just say, I want this stuff, give it to me. Mr. McIntyre didn't show any cause. He didn't say, I think you've screwed up. I think you've done something wrong. I want the data for this and this reason. It was just, I want what you've done. And I'm going to determine what bits and pieces I want to audit. That was and remains deeply troubling to me. And it's unclear to me, even with the new administration, how the new administration is going to deal with that kind of, one colleague put it, denial of service attack. You know, denial of service is when you overwhelm some server with lots and lots of requests. And I think that colleague was quite right to use this kind of analogy. This is a denial of service. This is a pattern of behavior here. These sorts of requests are being directed towards those whose research suggests that there is a human effect on climate. It's asymmetric, and I believe it's frivolous. How the administration is going to handle this, I don't know. We're waiting to see.
Well, that's a really stunning response. I assumed that when the new administration came in, that this appears to be some type of politically motivated action, and I would have thought that they would give you good legal advice. I mean, you work for the Department of Energy at Lawrence Livermore.
Yes, I do.
I mean, that is a very well-established, long-standing department. I mean, you're saying that they told you, well, you're on your own, and we're not going to support you, and we're not going to allow you to continue your science.
No. The question is, well, it's sort of a comment more that this is surprising, and what has the reaction of the Department of Energy been? The Department of Energy, I hope I'm off the record here. I guess I'm on the camera.
Never off the record.
Okay.
It's a phrase to just put out everything. Yeah.
I've been somewhat disappointed, I would have to say. The Department of Energy, in the aftermath of ClimateGate, has not said, we stand behind this work here, this particular paper that Ben Santer and his colleagues published. We believe these attacks are politically motivated. And I understand realpolitik. I understand how it might be difficult for an agency to make those kind of statements in public, but they've not even made those statements in private. You know, nobody has called up and said, hey, in a sense, we're the ones who got you into this mess because we asked you to comment on this paper. Nothing.
Former boss is now head of the
Not my boss. No, he was at Lawrence Berkeley National Lab. I'm at Livermore. But I think that ultimately this administration has to deal with these kind of issues. You know, ClimateGate, in my mind, does reveal this abuse of the Freedom of Information Act request to use it as a tool for harassing people rather than for valid scientific discovery. And that is troubling, and I believe that others will be emboldened by these kind of successes to do more of the same in the future, unless there are clear guidelines as to what is or what is not subject to Freedom of Information Act requests. The letter I received from Senator Inhofe at the start of ClimateGate was basically a sort of hold notice that I'm not to delete any of my email correspondence related to the Climatic Research Unit. That email correspondence goes back 20 years. Copies have been made of the disks of all my computers, my laptop, my workstation, my two workstations. So this is a new reality now, and how government agencies that fund the kind of work that I do will deal with this new reality, I do not know. Yes, sir?
Yeah, well, first of all, I guess I'm surprised that Inhofe was able to get off his knuckles long enough to send you an email. That's neither here nor there. What I'm curious about, you mentioned it earlier, is whether or not...
Actually, can I respond to that one first? Yeah. So the question was, you were surprised, expressing surprise that Senator Inhofe actually managed to send me an email. He didn't. He made some blanket press release on his website that named me and a number of other scientists. And he actually misidentified the UK Climatic Research Unit and said in that press release that all correspondence between these scientists and the Hadley Climate Research Unit, an entity that does not exist, needed to be preserved from destruction. Eventually, however, someone cottoned on that putting a sort of stop notice on email destruction for an entity that does not exist is maybe not such a good idea. So then about a week ago or so, after 3 months, they finally sent me another letter with the proper identification of the UK Climatic Research Unit. So things work slowly, obviously, in Senator Inhofe's office.
My question is, I guess, more of a sense of what your sense is as to whether or not this sort of tactic, these tactics, will escalate in the future as the topic of climate change becomes more and more prevalent in the public discussion. And do you think, I mean, I think it's quite obvious that it will have a chilling effect, but I'm wondering if you've given much thought as far as how that will quash the debate or stifle the discussion, and what side issues might also, unanticipated side issues might arise as a result of that.
Okay, so the question was, will this kind of behavior continue and even expand in the future? What might some of the consequences of this use of FOIA, congressional investigation, have on other scientists, particularly young scientists coming into the field? I think this will continue, as I said, unless the government is capable of making clear guidelines of what is and what is not subject to Freedom of Information Act requests. This sort of thing is clearly going to continue. And unless there is some form of political pushback against this, this will continue. This has been very effective. And there are currently Freedom of Information Act requests to colleagues of mine for, in one case, emails that include the word delete. I'm not kidding you. All emails that include the word delete, all words, that include climatic research unit, hockey stick. So these are gigantic fishing expeditions, and it is troubling, I think, that there's no clear sense of how the administration is going to respond to these things.
You think that pushback might come in the form of, and I hate to sound so melodramatic, but hearing this, I immediately think of Joseph McCarthy. And the fact that he was dragging people out of their houses and in front of his committee for as long as he did, and that at some point there was just this indignation that came about where I think, as I understand it, there was a pushback when people just said enough is enough. And I'm wondering if that pushback will come from the scientific community, will it come from the academic community, or?
I don't know. I was talking to Steve about that over dinner. I keep on thinking the pendulum has swung about as far as it can possibly swing, and then it goes a bit further, as with this latest Inhofe thing. I mean, talking of criminal prosecution and again, I believe it is McCarthyism. I really do. This is targeting of individuals because of the work they do and because of what that work shows. It's as simple as that. It is chilling, I think, for young people, but I guess the encouraging or the encouragement that I would like to give people in the audience who are thinking of working on these issues is don't give up. Work on this stuff. It's critically important. You can't be silenced by the likes of these guys at all. One cannot leave the playing field to these sort of customers here.
One thing I just don't understand is that
Yes.
the Freedom of Information Act requests for plenty of other data, like photographs of people killed in the Gulf War, etc., take years to process. Why are you guys being so efficient? Just take longer.
We were given...
You're overemploying somebody. You need to make some budget cuts so that those requests take a lot longer.
We were given 20 days to respond. Sorry. So the question was, why are we so efficient at responding to these things, and why not just delay and take a lot of time? Or one suggestion was actually to provide data in hard copy form, thousands and thousands of pages of things, and
DOE management give you 20 days? Was it DOE management that came down to you specifically and said you have 20 days to respond? I mean, where in the as I understand it, freedom of information goes to governmental organizations, and they have to respond.
Right.
And it's the management in the organization that needs to take a position one way or the other.
yeah, it went to the second request went to the Department of Energy, and there are different components, of course, of the Department of Energy. There's the Office of Science. They're the people who actually fund our work. But Livermore is a so-called NNSA lab, National Nuclear Security Administration lab. And the Freedom of Information Act request went to them, interestingly, because it was perceived, I think, that they would be less likely to want to delay things. And we were told, provide some response to this request within 20 days. Yes?
This goes back to Steve's question about who peer-reviewed the Douglas paper. And then, given your paper, shouldn't the editor ask for a response from Douglas to directly respond to your issues? And if they would refuse, shouldn't they ask them to retract that paper or whatever is appropriate?
Yeah, so the question is about the sort of editorial response to the Douglas et al. Paper and the review of the Douglas et al. Paper, what happened. Unfortunately, I'm not at liberty to tell you much of what happened during the review process for the Douglas et al. Paper. I do know that the paper had 2 reviewers. I know that one of the paper's reviewers was an eminent statistician. I know that that statistician raised serious concerns about the paper. I know that the paper's authors basically said, trust John Christie. He's been doing this stuff for 20 years. And that was judged to be an adequate response. The editor was...
About as well as he does most things.
The editor was not knowledgeable about these issues, and the editor published the paper. I think it became very quickly apparent to the International Journal of Climatology that something was amiss. I believe they were contacted by people at the Royal Meteorological Society, the Hadley Center for Climate Prediction and Research in the UK. People had serious concerns about this paper. By that time, I was already engaged in trying to set the scientific record straight and respond to this thing. I contacted someone who was on the editorial board of the International Journal of Climatology, Dr. Tim Osborne, and I wanted to give the International Journal the opportunity to set the record straight on their own pages. As I saw it, they published a flawed paper. They should have the opportunity to set the record straight. I should also point out that the flawed paper, the Douglas et al. Paper, was essentially a commentary on papers that my colleagues and I had published. We had not been given a chance to review their paper at all. We had not seen it until I received a copy of the paper from Andy Revkin just before it was about to go online. So there are many, many aspects of this whole thing that were troubling. Again, I thought after we had done a significant amount of new work in order to expose the statistical errors, to do the statistics right, to do all this testing with synthetic data, with random data, to show how these tests behaved under controlled conditions, that our paper was much more than just a comment on Douglas et al. It was a standalone, independent piece of science and should therefore be published not as a comment on Douglas et al., but as a standalone paper. That has now been portrayed, that message was one of the ones in the hacked emails as me exerting evil influence on the journal to do my bidding. I believe psychologists call that kind of behavior projection, when you actually project onto others your own values and beliefs and behavioral patterns. From my point of view, we did absolutely nothing wrong here. We did the science in order to address a flawed paper. We published that. It was entirely appropriate to ask whether our paper would be considered a standalone contribution. It was, it should have been, and I had no control over the decision to hold back the print version of their paper, which in the end, the print version wasn't the one that got the attention. It was the online paper that had been published 10 months before ours that got all the Fox News and Press Club and all that sort of stuff. So I think this was some failure of the peer review system. Those things happen. And again, there's no magical self-correction mechanism. It's incumbent on all of us. That's the job of the many, not the few, to remedy those kind of flawed papers when they are published. Yes?
First of all, I really want to thank you for all the work that you've done and the risk that you're taking and the amount of courage it takes to continue. I think it's really wonderful. And then I have three little parts. One is, Stephen McIntyre, his character who funds him, how did he become the auditor? And for the Freedom of Information Act, why the Department of Energy would allow information that's actually about global or national security. It was an agency's record, and so in some ways they are threatening our national security, especially if you're working with nuclear secrets or science. There is information that is not free for everyone to see. And so who checks into how this could affect our national security as far as just a way of maybe combating them? And then quickly, as a pushback, you got to repeat all this word for word.
Okay, so
all of us working for this, and all of us defending you and the science, and everyone that knows about this, and that, and I think it's just so important that we all work every day at pushing back against this. So thank you.
Well, thank you for your kind remarks. First of all, I think that it's part of being a scientist. I mean, we have the responsibility not only to do research, but also to set the scientific record straight, to point out abuses when extraordinary and wrong claims are being made on the basis of demonstrably flawed stuff. You can't ignore it. You can't let it slide. If you do, that contributes to public misunderstanding of the most basic elements of climate science. And people say, well, yeah, you know, I don't believe any of this stuff because the satellite data. These guys showed that the atmosphere is cooling, and as I've showed you, many people remember that the atmosphere is cooling claim. Very few people remember that claim was made on the basis of a sign error. That the guys got the sign wrong. You know, many people believe and remember the Douglas et al. Claim. Didn't these guys show that models and observations are just at odds and they're really statistically significantly different? That got on Fox News. Nobody remembers that another paper came along and showed that these guys had screwed up the most basic statistical test. So it is incumbent on all of us to set the record straight. Now, with regard to the second part of your question, this issue of whether there are aspects of the work that we do, I think that was the question, that should make this stuff immune to Freedom of Information Act requests. I don't know the answer to that. I've heard a lot about what's called the deliberative process, that email correspondence generated during the course of work on a scientific paper is, at least in some agencies, considered part of the deliberative process and therefore not subject to Freedom of Information Act requests. One of the problems, I think, is that the implementation of the Freedom of Information Act is not the same across agencies. Different agencies have different exclusions, and that was a big surprise to me. I thought that this was some federal act and that everybody had the same exclusions and exemptions, but that's not the case at all. Even within the Department of Energy, the exclusions and exemptions for the Office of Science and the NNSA labs are different.
So anyone, regardless, could just request this? You know, anybody. Who is Stephen McIntosh?
He is a retired Canadian mining engineer. He's not a climate scientist. He's not a U.S. citizen, which is also troubling. But apparently you do not have to be a U.S. citizen in order to make Freedom of Information Act requests. I didn't realize that either.
So petroleum investor.
Yeah.
And did you make a counter request for information about, for him to release his information, all of his emails and who's paying for him? I mean, has anyone, because I'll write it up. I want to get up his butt really.
Yeah, he's not a U.S. citizen. He's not funded by the government. That's my problem. I'm funded by the government. And
funded by the government, there's nobody that can figure him out, really, in a detailed manner.
I think that one of the things that's happened in the aftermath of ClimateGate is that people are now devoting more attention to some of these folks and trying to understand who is funding them, why they're doing the things that they're doing. I think that is happening now, but it's a slower process. I think what we saw initially, as Steve probably told you, is a lot of, sort of gotcha dog pile type journalism. Let's jump on the pile here, and not the thoughtful investigative reporting that we should have seen. Who are the people who are responsible for these systematic Freedom of Information Act requests? Are they truly interested in better understanding the science, or do they have other motives? How have they behaved in examples like this, where there was a clear asymmetry? The wrong paper doesn't get any attention, and the people who are attempting to set the scientific record straight get all of the attention. These sort of things, I hope, will come out in the next several months or so. The bottom line is that no matter how loudly these guys shout and scream, you can't change the science. Ultimately, scientific truth will prevail, I think, no matter how loudly these forces of unreason shout. Yes?
So I want to just point out that we're living in a whole new era from the era that most of us grew up in this room, some of the students accepted here. And as a parent, I'm learning about social networking and blogging and all this stuff that goes on that my children have to deal with when they're out there on the internet saying things. They have to be aware of this broad leverage that the internet gives in terms of sending messaging really, really far out. So the question I have for you is, how are you dealing with a whole new era of social media, social networking, blogging, yourself as part of the way that you reach out more broadly to the public to get this record on the way you have described it, but also with your links and with your studies and with your data, because they are leveraging this to rile up people. They're counterforces of very academic and scientific, progressive-minded blogs and social networking sites that want to understand this just as well, who you should be working with to provide your defense. Because in a courtroom, when somebody accuses you of something and you don't immediately defend yourself, there's a sort of an assumption or presumption of guilt. Social networking, I think it's very similar. If somebody on a blog is accusing you of things, you have to either on their blog or on your own blog be providing the response. And so have you been advised on this? Do you have a strategy, and are you doing that kind of thing?
Sure, well, that's a great question, and I guess the question boils down to this. The essence of the question boils down to this. How is blogging affecting me, first of all, and am I using the internet in some kind of constructive way to get my side of the story out?
That was really good.
Oh, thank you. Blogging is affecting me profoundly. Obviously, Mr. McIntyre has profoundly affected my life. He's profoundly affected Phil Jones's life. He's affected the lives of many of my colleagues, and is likely to do so in the future. Again, I think there's a game here that this self-appointed auditor can request whatever he wants from climate scientists. He can use the power of his website to stir people up into some frenzy, get them all riled up. So-and-so has not given me exactly what I wanted. Do something about it. Write to so-and-so's superiors. Complain to his funding agency. All of this stuff happens. People send you threatening emails. People send you more than just threatening emails. They actually sometimes do things as well. And it's in part, I think, based on this intemperate language that goes on in some of these websites, and in part because of the intemperate language of people like Senator Inhofe, who refers to us now as criminals and climate science as a hoax and fraudulent. Those sort of words are not conducive to rational debate, rational public discourse at all. No, I'm not. As I said, for the last 3.5 months, I've just been responding because I take your point. I saw what happened with Phil Jones. I think Phil decided at the Climatic Research Unit that the best strategy was just to lay low and hope that everything would blow over. And that doesn't happen. You have to respond to these things. Otherwise, it's guilty as charged. I learned that at the time of the second assessment report back in 1996. What I've been trying to do is, instead of writing a blog, I've written a series of open letters. The latest one was released yesterday on Real Climate. These letters have a couple of functions. The first were to defend friends and colleagues who have been unjustly accused of very serious professional misconduct. The most recent two were to defend me. And I've requested against the allegations that I mentioned here, professional misconduct in our response to the Douglas et al. Paper, and misconduct in how we responded to Stephen McIntyre's Freedom of Information Act request. Those are two of the principal allegations against me. The third allegation really relates to 1996 and my service as convening lead author of Chapter 8 of the second assessment report. That's been been given new life by this guy, Lord Monckton, who has sort of resuscitated that thing. So I've tried to address the allegations, to refute them, to link with previously published material, particularly for the 1996 stuff. That was distributed in many different fora. The Wall Street Journal, Nature, Science, the IPCC had defended me, other scientists had defended me. A lot of stuff is out there, but it wasn't easily accessible for people. So I've actually invested a lot of time in order to make it accessible. And the internet has proved a very effective medium for doing that. I do not have a blog. I still believe that the best contribution I can make is by continuing to do science. That's all I really want to do. The supreme irony in my scientific career is that I'm a very private person. I hate this kind of stuff. I love doing science, and that's all I want to do. And I don't want to have the rest of my research career dictated by the likes of David Douglas and John Christie and Stephen McIntyre. I'd prefer to be proactive about the work that I do, not reactive all the time. But you have to respond. It's a real catch-22 situation. When do you fight? When do you engage? When do you disengage and try and get on with your life? When do you?
They don't want to touch this.
Yeah.
They couldn't get on with Science Contacts, but they said they're not interested in this kind of stuff.
Yeah.
They told the National Geographic publicist. Or that's one thing, but they don't want to get into this.
I don't know what the right balance is. I don't know. I do know that there are a lot of great blogs out there. I particularly salute, the stuff that Steve has been doing for a long time now, the stuff that the folks at Real Climate are doing. They're really, as I said in yesterday's open letter, like Carl Sagan's famous saying, they're a candle in the darkness. There's a lot of darkness out there, and there are a lot of people spending significant amounts of their free time addressing this kind of stuff and making sure that things are not left unchallenged, that outrageous statements and myths and lies and disinformation, that they are challenged. I applaud those people, I really do. But for me, I think the best strategy is just to continue to do the science. Yes?
As the previous questioner said, I really thank you for everything you've done. I think it's a real injustice what you've suffered over many years, and you're suffering now, so I hope that changes soon. I also want to ask two questions. One has to do with the statistics, and the other has to do with your professional standards. So the statistical one is, when you went back and looked at the earlier paper, why did you include in the range of observations that a data set or result that you had previously found to be untrustworthy or false? That didn't make any sense to me. So why, when you said you had the band up here and you had the black dot and the open dot,
yeah, let me go.
I've got the words. It's why did you include the lower one if you'd already found that those sets of observations were false?
That's a good question, and okay, yeah, here it is. So, so you're referring to this one here. Okay, let me just repeat that question. So the question was about the University of Alabama data. That's the open dot here, and our the previous part of my talk had shown that dot was wrong. But if you remember, those guys had a sign error. They actually admitted that sign error in Science, and they were confronted again with pretty irrefutable evidence that they were wrong. If you look at this dot here, you can see that this is actually above the 0 line. So they made a change to their data. Okay. They said the sign errors, yeah, okay, we made a mistake. We're going to adjust for that. The curious thing was that when they made the adjustment, it didn't change very much. It changed only a relatively minor amount, which still remains very, very puzzling. There are now 4 groups that have used the same satellite data to do these reconstructions of atmospheric temperature change. 3 of them now are sort of up here in this vicinity with the solid dot there. The Alabama group is down here for reasons that we don't understand. But I included it because Douglas et al. Had looked at it. So one of the things was to try and replicate their analysis as closely as possible, but doing the statistics right. And I included it also because this was the corrected version of the Alabama data set that had, nominally accounted for this sign error.
Okay. And then the second question I had, it relates to professional standards. I
Sure.
think this question of what one should provide at their FOIA request is very difficult. And so one thing I've thought about is that perhaps, the field of climatology or climate science, one standard that could be used relates to what are the sets of standards of information that you would provide to a reviewing reader or judge in a peer-reviewed journal. So if you submitted a paper for publication and you get a request from someone who's reviewing the paper and they wanted to see some stuff, I guess the question I have is there a well-defined standard for what an author should submit to a reviewer on request? Now, maybe there isn't one, but if there is, what is it?
Okay, well, that's a great question. The question is, are there well-defined standards then in terms of the data that one should supply to some auditor or some requester under the Freedom of Information Act? Is it?
No, I'm not actually asking about the Freedom of Information Act. I'm asking about the journal publication standards.
Okay, so what are the journal standards in terms of providing data to reviewers? That's your question.
Yeah, essentially.
Steve, being the editor of Climatic Change, is much better placed to answer that, so I'll let him say something in just a second. But I think there is, correct me if I'm wrong here, Steve, there's no uniform policy across journals. Is that right?
Have you repeat it? No, there's no uniform policy across journals. And in fact, McIntyre asked me as editor of Climatic Change to insist that I think Mann and Malcolm Hughes, something that they had published in Climatic Change, send them their source code. That's the computer code handwritten by them. And my first reaction was, nobody's ever asked for that before, and nobody's ever needed it in 1,000 papers we've reviewed, but all right. So I sent it out to the editorial board and asked them, and you were one of them. And we had about a month-and-a-half long debate. There were one or two people who thought, well, you just give everybody everything. There were others who said and pointed out quite correctly, wait a minute, we have limited resources, we have limited funding, and those codes that are written for public consumption, like the Community Climate Model at the National Center for Atmospheric Research, they have a team of 4 programmers for every scientist to document every detail of that code. How could scientists who write their own idiosyncratic codes, they would get a quarter of their work done if they were trying to write a polished product for export? It's also an interference with intellectual property, because these, in our business, promotions are based upon reputation, which is based upon papers. If somebody comes in and immediately gets your code and they got 3 programmers, they'll be publishing more stuff with your work than you are and getting ahead of you. It is a real absolute negative incentive for anybody to do that. So what we concluded was that anybody who gets a code with idiosyncratic, undocumented components will probably use it wrong, and it won't be helpful. So what we want is replication. And in fact, replication is most independent with independent codes. Data should be available. All algorithms, and methods should be clearly available or standard, and that individuals who wish to replicate should in fact do their own computer codes using those methods and data, or alternative methods and data, which I think I showed in here not all that long ago, where you looked at the 12 hockey sticks where people made different assumptions about how to calibrate temperature to tree ring width, for example. And that the process of science is much better served by having independent codes, because otherwise people could miss code errors and be repeating them, so you'd have a lack of genetic diversity in the codes. We don't think it's good for science, and we think it's very, very bad for investigators to be spending 2/3 of their time writing documented statements in codes. Now, if you're in certain groups which have QA or quality assurance, and that's part of the contract, you have to convince the quality assurance officer you're doing it, well, the grant is going to have a budget for that. How are you going to do that as an individual and be productive? So my journal at least decided that the data had to be there, as I said, the methods had to be very explicit and clear, no hidden, how you did the equations, and that algorithms that you used were there, but that the codes were not to be provided. And in fact, the National Science Foundation very recently has agreed that its investigators are not required to turn over personal source code to any request. So that's where we are now. It's pretty much the same at Science. Don Kennedy told me a number of years ago. They're kind of encouraging people to give anything they can give, and me too, but I'm not going to make somebody sit there and spend 3 months of their lives trying to document a code that they wrote 8 years ago. I couldn't even remember what I wrote 8 years ago.
Yeah, and again, just following up from what Steve said, the key thing here is not only were the primary model data available to Mr. McIntyre, the algorithms that we used to do the intermediate calculations had been published. They were available in the peer-reviewed literature. The statistics, our statistical tests, were spelled out in excruciating detail in our paper. There was never any question on the reproducibility issue. This man had access to all the information that he needed in order to try and replicate our calculations and figure out whether we had reached appropriate conclusions. And again, the irony here, as I mentioned, is that Douglas et al. Had already sort of audited the intermediate calculations. McIntyre was unwilling to do that. Yes?
I'm wondering, to whom I can write outraged letters about this. Are there people in the agencies or Congress that you see as potential champions for helping create the right environment for science that we want and need?
Okay, so the question was, what can you do about this, and are there appropriate channels to express dismay, displeasure, unhappiness, concern? I don't know the answer to that question. I wish there was. I hope there will be some pushback. Now, I think this latest swing of the pendulum that was mentioned today with criminal prosecution or things like that being threatened may hopefully get some attention. The only crime I'm guilty of, in my mind, is trying to set the scientific record straight. I don't think that's a crime yet, and I don't want to live in any country where that is a crime. So I hope that people in the end recognize that this is not a political issue. This is not an ideological issue. It should not be. It's a scientific issue. It behooves all of us to understand the science, to take decisions on what to do about it on the basis of the best available science. Clearly, the Douglas et al. Paper was not the best available science. Extraordinary and false claims were made on the basis of that, and it's sad how those claims are now being accepted as the truth and woven into the fabric of these kind of criminal prosecution things. But in the end, the climate system, no matter how loudly these people can scream, the climate system is not going to be changed by this. It's not going to be phased by this. It will continue to warm. The sad thing is that action on addressing that root problem will likely be delayed because of this disinformation.
It's already been delayed 20 years.
Exactly.
So
That's what it's about.
please join me. Thank you.
I just want to suggest a couple of things. First of all, this has become political. If you are interested in engaging, I suggest that you engage at the senatorial level, because there is going to be a discussion at that level, and you have every right as a citizen to address your senators on this issue, and I encourage you all to do that. The second thing I just wanted to say is that for a moment there, I thought we were talking about fisheries. Because for those of us who have worked in the marine realm and in management of marine resources, it is the norm to be subject to personal attacks. I have spent the last 15 years of my life being active in public service, and I've had my own life threatened. I've had my children's life threatened. I've had all 4 tires spiked. I have had to use wardens to go in and out of meetings where I'm serving my own state to make decisions about our marine resources. So this is really common. And the social norm that now, really governs how we deal with one another as professionals has really changed, or perhaps maybe we've gone back in time. So I think this is a really rich discussion that we could have, and I'm very sorry to see that it's now the norm in your area too. And I just really want to thank you for being so open and honest and so eloquent about your experience.
Thank you. Thank you very much for inviting me. And I just wanted to say finally that the information that I've presented today, I'll make that available. You're more than welcome to have that. And the 4 open letters that I mentioned, Steve has them, I think. If not, contact me. Steve knows my email address. And sorry? Aren't they up at Real Climate? The most recent one is up on Real Climate.
The other one of them's up at DSmog blog.
One of them's, the third one is up at DSmog blog, but others, the first 2 may not be. And I'm very happy to distribute them and give them to you. Yeah.
For more, please visit us at stanford.edu.